this last part of this module, finishing up Newton's second law, we're now going to try to put everything we've learned so far in the course into some perspective, because next we're going to move on and we're going to add even more problem-solving concepts. We're going to have work and kinetic energy, conservation of energy, impulse, momentum, conservation momentum, and then we'll head into rotation. So we really want to solidify what we know so far. And as you've seen, these problems that combine or that have multiple steps are becoming more and more important and are going to get more and more complex as the semester moves on. So let's take a second and just sort of see what these combined concepts look like. We really haven't added any new problem-solving concepts than what we had before. We still have the standard ones from the previous module, and now we just have some details with Newton's second law involving either circular motion or ramps or friction. But let's talk about what a good plan sounds like when it tells you to write a plan. So for example, let's say that we have Atwood's machine, which just means that we have a pulley with two masses on it. And, let's call this M1 and M2. And let's say that M1 is greater than M2. So this is accelerating as I have it there. And let's say that you're asked to find the time it takes M1 to fall a distance L starting from rest. So if you were going to solve this problem, hopefully you can recognize that, okay, you have two masses and a pulley. You're going to have to use Newton's second law, write an equation of motion for each object. So you'll have an equation of motion for M1, you'll have an equation of motion for M2. You would solve that and then use that as part of your solution. But the question is, how do you want to phrase kind of this plan? So when you write a good plan, the way you want to do it is it kind of can always have the same phrasing. Step one, we'll use, and then we're going to put in our problem-solving concept, whatever that problem-solving concept is. We identified this as Newton's second law. So you're going to use Newton's second law, and then to get, what are you going to do with Newton's second law? What's the goal of that step? And Newton's second law, very often the goal is to get acceleration, because you want to figure out the acceleration of a system given insight into the individual forces. So I will use Newton's second law to get, and then you can fill in this blank. And in this case, again, it would be to get acceleration. And so that would be our first step, because the problem didn't ask for acceleration, it asked for the time. So acceleration is useful because then we can go back and we would just simply have our 1D motion for M1. If we knew the acceleration of M1 and it started from rest, it's what time does it take to fall a distance L? Well, that's just a very simple constant acceleration 1D motion problem. So step two then could be written as I will use, and again, our problem-solving concept, I will use, and in this case, it's 1D motion with constant acceleration, because we have constant and non-constant, and they have different problem approaches. So I will use 1D motion with constant acceleration to get, and this is actually my last step because there are just two steps for this problem. And so this one would be the time to fall a distance L. So by filling in these blanks, I will use blank to get blank. And then step two, I will use blank to get blank. And then eventually we'll have step three or step four. Eventually you're going to start and end up with, the answer at the end of this all. I don't know what that is. All right, so writing a good plan is important. Being able to articulate when you're using which problem-solving concept and what the goal of that problem-solving concept is important. So just practice that skill on the combined concept problems that you're provided in the module assignment, and ask any questions you have.